Okay, let's do the 2023 questions from the exam with relation to logarithms. So the value V in dollars of a laptop modeled by V equals 40 plus K e to the negative 0.5 t is equal to greater than 0, where t is the time in years since the laptop was purchased. The original price was $900. How long does it take for the laptop's value to be reduced to 50% of the original value? Okay, well, the first thing that's bothering me is this K thing. So we need to solve K before we can do anything. So we're given a little bit more information than it might look. We're told that the value at time 0 is 900. So in other words, when t equals 0, v equals 900. Okay, so that means that is 40 plus k e to the 0, because negative 0.5 times 0 is 0. And we know that that's just 1. So therefore, k must be 900 minus 40, which is 860. Okay, so that's k done. So half the value, 50% of the value would be $450, wouldn't it? Yeah. So we're going to set that the value equal to 450 and then solve for t. Plus, and the number was 860 e to the negative 0.5 t. Let's take the 40 away from both sides. So 410 equals 860 e to the negative 0.5 t, and let's divide both sides by 860, sorry. So e, I can come up here, e to the negative 0.5 t is going to be equal to 410 over 860, and I guess you'd cancel that as well, so that's going to be equal to 41 over 86. And now let's take the natural log of both sides. So that's going to cancel, because the natural log of e is 1. So 0.5t is going to equal the natural log of whatever that is, and t is going to be equal to that natural log divided by negative 0.5. Log of a fraction is going to be a negative number, so they're going to cancel. So therefore, I think we can grab our calculator. So the natural log 41 over 86, is that a negative number? Divide that by negative 0.5, 1.48155, so 1.48 years. So I guess you could say 1.5 years. Yeah, I'm happy with that. Right, the next questions. This one here, so log base 2, 3m plus 1 equals 4. So if you remember, that means that 2 to the power of 4 must be equal to 3m plus 1. So 2 to the power of 4 is going to be 16, because 2 times 2 times 2 times 2 is 16, equals 3m plus 1. Take 1 away from both sides. 3m there. So m must be 5. That's our answer. So just go through it again. So we rewrote it so that it was 2 to the power of 4 equals 3m plus 1. We know that 2 to the power of 4 is 16, we took one away from both sides. So 3m is equal to 15. Divide both sides by 3. So m equals 5. Okay, same thing for this. So log base x, so the thing we're trying to find is in the base, is 64 equals 6. So let's divide both sides by 3, which we can do. So log base x of 64 equals 2. So if we want to rewrite that, that would be rewritten as x squared equals 64. So x is going to equal plus minus 8. But of course, x must be equal to positive 8 because you can't have a base of a negative number. You can't do that. So x is positive 8. This is quite a cool problem. So we want to find a value. So in other words, we need some number that we can put in there. So 6 is find the value of 6 plus log b of 1 over b cubed plus log b of square root b. Well, the 6 is going to carry down. Now, 1 over b cubed is the same as b to the power of negative 3. And when we take the log, the negative 3 can come out the front. So therefore, log b of b negative 3 is going to be equal to negative 3 log b of b. And that's going to just equal 1. So it's going to be negative 3. So this bit here is going to be equal to negative 3. Okay, same logic holds for this bit here. So b, the square root of b, is the same as b to the power of half. So therefore, when we take log b of b to the half, that's going to be the same as the half. The half comes out the front. Log b of b, and that's going to be equal to 1 as well. So that's going to be equal to a half. So it's going to be 6 minus 3 plus a half. So it's going to be 2.5, 2.5. All right, so this one, it's in the algebra section, so we're going to solve it algebraically. And I suspect that our best, I suspect our best thing there is to use a u substitution. So let's let u be equal to 4 to the x, and we'll deal with that a little bit later. So therefore, we can rewrite this as u minus 10 over u. Yeah, I can see where we're going to go now. It's going to be equal to 3. Now, this might look like we can't solve it, but we actually can. Let's multiply the whole thing by u, so that we have u squared minus u, because u times 10 over u equals u, equals 10. Equals 10. No. U squared minus 10, and that's going to equal 3u. Yes. Makes sense? Yeah, it does make sense. So let's take 3u from both sides. So now we have u squared minus 3u minus 10 equals 0. So now we have a kind of quadratic in disguise. All right, so let's factorize it to solve it. So we need two things that multiply together to give us negative 10 and add to give us negative 3. Well, it's going to be minus 5 and plus 2. So it's going to be u minus 5, u plus 2 equals 0. So u minus 5 equals 0, u plus 2 equals 0, so u equals 5 and negative 2. Now, do any of these actually work? Okay, let's, I suspect we're going to have some trouble when we come to do logs. So, therefore, u, let's let u, we know that it equals to 4x, and we know that u equals, one of our solutions is 5. So, therefore, if we take the log of both sides, so the x comes out the front. So, x is going to be equal to log 5 over, what happened there? Log 4. That's going to be a solution. A log over another log is a solution. And I think we're going to come a cropper when we do it for negative 2. But let's have a look. So 4x equals negative 2. And then, yeah, when we take the log of negative 2. Ooh, is it going to give us an answer? Don't think that's going to give us an answer. Oh, let's have a look. So this one here is going to be log of 5 divided by log of 4, which is 1.16. 1 3dp, and log of negative 2. Yeah, math error, non-real error. So log of negative 2, log of negative 2 is going to give us a non-real error, which means that there's a solution, but it's a complex error. It needs imaginary numbers. So therefore, our only viable answer is that x equals log of 5 over log of 4, which is 1.161 to 3dp. And that's the logarithms for 2023.